So we've been asked to graph the following function, and it's a piecewise function. And then we've been asked down at the bottom of this page to find 4 function values. So I'm going to graph this function first. There are 2 ways to graph this. One way is to use translations. The other way is to plot points. If you want to use translations, it's a real simple graph. If you want to plot points, it takes a little more time, but again, not impossible. I'm going to start with this bottom function, which is a straight line, because it's very, very simple to graph. And you notice all of our axes here, 1, 2, 3, 4, 5, 1, 2, 3, 4. So everything's in a scale of 1. And this is my y-intercept is -5. Okay, so 1, 2, 3, 4, 5. I'm going to go down to -5, make a point. And my slope is -3/1. So that means I'm going to go down 1, 2, 3, and over 1. Or I could go up 1, 2, 3, and to the left 1. Either way works. And what do we see? We see that we have a straight line. This is supposed to graph a straight line. And the big thing is our domain says x has to be less than or equal to 1. So that means this point and left. Okay, so I'm going to pull out my ruler here, and we're going to graph this straight line. Okay, now there's our straight line, and it stops at x equals 1. Now the second one here, 1 over x minus 1, is a rational function, and it's going to make a really funny looking curve. If you know the base graph of 1 over x, then you can simply translate that base graph. Or you can plot points. Now it says x must be greater than 1. So what I like to do is I like to say, okay, let's make a table of x and y values. And I'm going to start at 1 and go to maybe 5. So 1 over 1 minus 1. What do you get? Okay? What's 1 minus 1? It's 0. It's 1 over 0. Okay? That doesn't work so well, does it? That's undefined. Notice it doesn't say equal to 1. There's a reason for that. Okay? How about 2? Well, 2 minus 1 is 1. And 1 over 1 is 1. So, ta-da, 1. How about 3? What's 3 minus 1 is 2. So 1 over 2 is 1/2. 4? Well, 4 minus 1 is 3. 1 over 3 is 1/3. And how about 5? 5 minus 1 is 4. 1 over 4 is 1/4. And so basically what this graph looks like is that x equals 2, y equals 1. At x equals 3, it equals 1/2, 1/3, 1/4. And so this graph typically is going to come from up here and go down and then slowly get closer and closer to the x-axis. Okay? In this particular case, it's going to look something like this. And normally this graph is going to go upward. And if you don't believe me, you could very, very simply try a point. Instead of 1 or 2, try something like maybe 1.5. What is 1.5 minus 1? It's a half. What's 1 divided by a half? It's 2. So at 1.5, the y value should be right here. It should be 2. How about 1 and 1/8? Well, 1 and 1/8 minus 1 is an eighth. 1 divided by an eighth is 8. And so this graph, as it gets closer to 1, is going to go way, way, way up here. Okay? So this is what this graph should look like. And a real simple way to check this is with your graphing calculator. You can take your handy-dandy little TI-83 and you can go to y equals, and you can type 1 divided by x minus 1 and press graph. And I've got an odd window here, so we can go to zoom standard, and this will give me an odd, well, let me reset my window to something a little simpler here. -5 and 5, -10 and 10, so that it looks more normal. The graph rides along the x-axis and curves down. There's a vertical asymptote here, which means that the function can't exist at that point. Well, that point happens to be x equals 1. And then the graph comes from down here at the top and is shaped like that. That's the graph of 1 over x. And basically we have from here over for 1 over x. Okay, so we've graphed this. Now they ask us 4 questions. They ask us f of negative 4, f of 0, f of 1, and f of 5. And there's a couple of things we can do here. One thing we can do is we can look at the graph. So I can say, okay, well, what is f of negative 4? And I can go to x equals negative 1, 2, 3, 4, and go up and say, well, it looks like it's right there. And I can use my graph. Or I can plug it into one of these functions algebraically. Well, it says if x is less than or equal to 1, I must use this function. So I plug negative 4 in for x. What is negative 3 times negative 4? It's 12. What is 12 minus 5? How about 7? Let's compare that to our graph for a second. If I go over to 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, ta-da, y equals 7. Isn't that nice? So our graph matches our math. How about f of 0? Well, since 0 is less than or equal to 1, I still have to use this function. So 3 times 0 is 0. 0 minus 5 would be negative 5. Well, let's check that. Here's x equals 0. Find where it hits the line. 1, 2, 3, 4, 5. So our graph checks that. How about f of 1? Well, this is greater than 1. This is less than or equal to 1. So since this has the equal to sign, we still have to use this function. So we plug in x equals 1. Negative 3 times 1 is negative 3. Negative 3 minus 5 gives me negative 8. And we can check this with our graph. Go to x equals 1 and go down 1, 2, 3, 4, 5, 6, 7, 8. Okay? So we know that checks with our graph. And the last one, f of 5. Here's the mistake you make. For the first 3 questions, you used this equation. And so for the 4th question, you'll try to use this equation. But the domain says less than or equal to 1. 5 is greater than 1. So we have to use this equation now. So 1 over x minus 1. Okay, so plug in x equals 5. What's 5 minus 1? 4. So your answer is 1 over 4. So what's the answer here? 1/4. And I know that's right because up here I actually plotted that exact point to get this line. So anyway, that's how we answer these function notation questions and how we can graph these lines. If you have any questions, please come see me.